All right, quick review on arcs. And first off, we're just going to fill in everything we can. So if you notice, sorry for the watermark, CE right here is a diameter, which means this is a semicircle equaling 180 degrees. So since we have 2 out of the 3 pie pieces, not evenly cut, or pizza slices, whatever, since we have 2 out of the 3, we can add those together and subtract from 180. Okay, so if we subtract, add 75 and 42, we get 117, and subtract, we get 63. Now notice, this also is a diameter, and this is also a semicircle. So now we have 2 out of 3 pie pieces, 63 and 75. If we add those two together, we get 138. If we subtract that from 180, we get 42. And since, if we look back at the blue semicircle, the left side, the right side is also a semicircle, meaning 180 minus 42 is 138. So before I try to answer any questions, I just wanted to fill in all my pie pieces. Now, let's see what we have. We're looking for AB. Okay, well, AB is right here. That's just 63 degrees. CD, right there, 42 degrees. These are both minor arcs. DE, again, minor arc, big one, but still minor, less than 180, is 138. BCD was a typo. It should just be BD. So please scratch that out. Because as you can tell, BCD, if you call it that, would not be a major arc. So we're just adding 75 and 42 to get 117. And then AED. AED is one of our other semicircles, 180. Okay, just quick review. Whoops, did not mean to do that. All right. The standard equation of a circle. This is pretty easy part here. It looks scary, but it's not. So, x, y represent any point on a circle. Okay? That point is going to be connected to the center. All right? And basically, you have your radius between hk and xy. Now, if you look here, this is x minus h, and this is y minus k. So if we have basically the Pythagorean theorem, x minus h squared, a squared, plus b squared equals c squared. All right? This is the standard equation of a circle. hk is our center, and r is the radius. Once again, it looks scarier than it really is. So write the standard equation of each circle. Okay. I like to always start, by writing my formulas somewhere where I can access them and just get in the habit of it because it just, ingrains the formula and also it's a good reference point. Write the standard equation of each circle, the circle shown at the left. Okay, so the circle shown at the left, here's my center, right? My radius is 1, 2, 3. 1, 2, 3. Okay, so my radius is 3. And since my center is at 0, 0, this goes pretty quickly. It's x minus 0 plus y minus 0, both of these squared, equals 3 squared. Well, x minus 0 is just x, so this is basically x squared plus y squared equals 9. All right? Now, you don't always have a picture. So here's where I say, as always, it's not a bad idea to write the formula first, like so, and put the minus in, because this is my x, this is my y. So it's going to be x minus 3, and y is negative 9. Most common mistake is just to write, oh, y minus 9. It's not. It's x minus 3 squared plus y plus 9 squared. That looks like a 4. Way too big. Squared equals 16. Okay. Moving on. The point negative 5, 6 is on a circle with the center 1, 3. So the radius is right here. Okay. Write the standard equation of the circle. All right. So we need to find out what that measurement is using the distance formula. Or if you think about it, this is also a radius. Or this is a radius. Or this is a radius. This is a radius. So we can actually cheat and just count. 1, 2, 3, 4, 5. The radius is 5. Now, just to refresh, I'm going to do the distance formula real quickly. And as always, I like to do this first. And then put in negative 5 and negative 1. And 6 and 3. So real quickly, that's going to be plus, right? So that's going to be negative 4 squared. Nope, not that. Plus 3 squared. So that's going to be 16 plus 9, square root of 25. Hey, r is 5. But once again, since that is a radius, you can just take the straight line over and count the radius. But I did want to refresh you on the distance formula. So now I have my radius, I have my point. So again, I'm going to do this, leave it open, and put in my radius squared, then put in my negative 5 and my 6. Simplify this. And that is the equation of that circle. Except I don't know why I wrote my bad. I don't know why I wrote the point. That was silly of me. I put the point in and not the center. So excuse me for being silly. Let's fix that. Hopefully you caught that. So x minus, we need a center, negative 1. I still have the double negative there. And 3. So this is plus 1 and minus 3. Sorry for that. Used the wrong point. But it's a good thing to pay attention to. Maybe I did it on purpose. When you're given 2 points like that, make sure you use the proper one, which is the center. All right. Example 3. We're going to do some graphing here. The equation of a circle is x minus 4 and y plus 2 squared equals 36. Find the center and the radius of the circle, then graph. All right, so that means my center is at 4, be careful here, negative 2. Square root of 36 is 6, so my radius is 6. So we're going to go to 4, negative 2, 1, 2, 3, 4, 1, 2. And we're going to count 6 every direction. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. And then we're going to do our best to draw a circle. That's not great, but it will do. All right, example 4. Prove or disprove that the point square root of 2 lies on the circle centered at 2, 0. Okay, so let me read that correctly. Lies on the circle centered at the origin containing the point 2, 0. Okay, so if, real quickly, the center is here, and a point on the circle is 1, 2, 0, well, that means 1, 2, 1, 2, 1, 2. So my circle looks like this, and my radius is 2. Since it's at the center, that means it's x minus 0 squared. If you want to go right to that because it's obvious to you, that's fine. Plus y minus 0 squared, or just simply y squared, equals 2 squared, which is 4. So that's the formula of the circle. We're going to plug in x and y here. So square root of 2 squared plus the square root of y, square root of 2, which is y, squared, equals 4. Well, a square times itself is just a number. 4 equals 4, check. Yes, radical 2 is on the circle. And that is it.